So today's objective, we're going to be focusing on simplifying radical expressions, which we've already done, but we're specifically going to focus on radical expressions that now have variables. So we're going to follow almost the exact same steps that we saw in the key points of our first video, but there's a few extra things we have to do when we start to add variables into our radicals. So if we quickly look over our key points, we can see that step one is that we need to factor the numbers using a factor tree, which is what we were doing before. The addition is that we now need to expand our variables. So that's something we didn't see before. Then we're going to be circling our prime numbers, rewriting them under the radical, just as we did before, checking the index to see how many groups of numbers we need to be looking for. Then we connect our groups with a line. We pull out one number, and again, this is something new, or one variable for each group that we have. And then the last step is multiply the parts that are inside and the parts that are outside. So let's look at example 1 and work through these key points. Factoring our numbers, we have been doing for the last couple days. So here 150 can be 15 times 10. I break 15 apart to be 3 and 5, and those are both prime. And 10 is 2 and 5, and those are also both prime. So I've circled my primes. I can rewrite them under the radical. So 3 times 5 times 2 times 5. Now, the part that's new is my expanding variables. Really all that means is p to the 5th is p 5 times. So I want to expand my variable 5 times. And that's also going to go underneath our root. So we have pretty much the prime factorization of our number and the prime factorization of our exponents. Now we want to check the index. Well, I don't have an index, so there we understand that that means the index is a 2. So I'm going to be looking for groups of 2. So I see 3 doesn't have any groups. 5, I do have a group, so I connect it with a line. 2 is by itself. And here I have a group of 2 p's, a group of 2 p's, and then this one's just extra. So I want to pull out one number for each group. So I have the 5s, the group of 5s, so that's going to come out. And now I also want to pull out one variable for each group. So here I have a p is going to come out. Here I have a second group, so that's another p that's going to come out, and then that p is going to stay. So I have a p come out, another one comes out. I have my square root, so this is gone, and 4 of these are gone. So I have a 3, a 2, and 1 p left inside. So in order to simplify this, I do the very last step, which is multiply the things inside and outside. So 5 times p is just going to become 5, and p times p, I know I add my exponents, becomes p squared. Then I have the square root of 3 times 2 is 6, and p stays inside. So it's really the almost identical key points, same procedure. We just have this extra idea of expanding our variables, pulling out letters for each group, and then simplifying the inside and the outside. So this is really just practicing our variables. Let's look at another example. Here we have a coefficient out in front, but let's follow the same steps. So if I have 248, I don't know those factors by automatically in my head, so I use my calculator and I divide, and I have 648 divided by 2, which gives me 234. So there's 2, oops, and 234. I can divide that by 2, and I get 162. Divide that by 2, and I get 81. 81 I know is 9 times 9, and 9 times 9 I know is 3 times 3, and 3 times 3. So here I have 3, 3, 3, and 3. So I have factored all of my primes. Now I need to expand my variables. So that means I have an n and an n. So I rewrite this under the radical. I have 1, 2, 3 2's. 1, 2, 3, 3 2's. And 4 3's. 1, 2, 3, 4. And my 2 n's. This is a fourth root. And my negative 2 was already out in front. This is a 2. So I check my index, and I see that I'm looking for groups of 4, so I only have a group of 3 2's. I have 4 3's, so I connect 1, 2, 3, 4 3's, which means I'm going to pull a group of 3's out. And I have 2 n's, which means I am not going to connect anything or pull anything out. So I have my negative 2 is already outside, the 3 from my group of 4 3's. Then I recopy my fourth root. All of my 2's stay inside, and all of my n's stay inside. So I multiply what's left out in front. Negative 2 times 3 is negative 6. I keep my fourth root, and I multiply 2 times 2 times 2, which is 8, and n times n, which is n squared. So really the only thing I could pull a group of 4 out was my 3's. Everything else stays inside. And that is my simplified radical. Alright, let's try one last example, and this is going to have 2 variables under my roots. So again, I'm going to follow the same steps. I simplify 48. I know that 48 is 6 times 8. 6 is 2 and 3, which are both prime. 8 is 2 and 4. 2 is prime. And 4 is 2 and 2. Here I want to expand 5 u's. So if I rewrite the third root of 2 times 3 times 2 times 2 times 2, and I want 1, 2, 3, 4, 5 u's, and 1, 2, 3, 4, 5, 6 v's. I want to look at my index and determine that I want groups of 3. So I have 2, 3, 4 2's, but I only want 3, so I'm going to connect 1, 2, 3, and this guy is just going to be off by himself. He doesn't have another group to connect with. 3 is by himself. I want to look for groups of 3 u's. I do have 1, 2, 3 u's, and 3 v's. 1, 2, 3 v's, and I do actually have extras 1, 2, 3 v's. So I'm going to pull out a 2, I'm going to pull out a group of u's, a group of v's, and another group of v's. So I didn't have anything out front originally, so I bring out my 2, my u, my v, and my v. I rewrite my third root, and if it helps to cross out the things you pulled out to see what's left over, that might be helpful. So then I have a 3, a 2, I have 2 u's left over, and I don't have any v's left over. So I multiply what's outside. 2 times u times v times v really is just going to stay as it is, but I can simplify my like terms. V to the 1 times v to the 1 is v squared. So 2uv squared to the third root. And then I multiply what's inside. 3 times 2 is 6. U times u is u squared. And I don't have any extra v's. I got rid of them all. So that is my final answer. So here is one where you can try on your own. We have the third root of 162, m, p to the fourth, q to the fifth. So go ahead, pause the video, do your work, follow your key steps, And when you start the video again, you can check your answer. Alright, so this should be the answer you got for number 4. If you didn't get it, make sure you were checking your index and pulling out groups of 3. Make sure that you didn't take anything that couldn't come out because it didn't have enough. And double check that you factored correctly. If you're still not able to find your mistake and get the correct answer, please come to class ready with questions. And the last thing we have are our 3 problems for our self-check. Copy these into your notes. Make sure that you complete them using your key points. And come ready to put this on your do now when you get to class.